Electric motors are made of two main components, one stationary, called a stator, the other a rotor that moves inside the stator. The stator has multiple wire coils. Running electricity through them creates a magnetic field that turns the rotor, creating mechanical power. The stator is lined with slots, each of which holds a copper coil. The more powerful the motor, the bigger the stator and the larger the slots. The first step is to line the slots with insulation. This insulation will keep the voltage confined to the coils. The coils are made from several copper wires wound together by machines. The bigger the motor, the more wires per coil. In this motor, each coil consists of 13 strands of copper wire. Now the workers tie the coils. This prevents the wires from unraveling while being inserted into the stator slots. Workers cap each coil with fiberglass insulation. Then they insulate the portion of the coil left outside the slots with fiberglass sheets. Then insert fiberglass wedges to lock the coils inside the slots. Once all the coils are inserted and insulated, workers begin preparing the connections. They slip an acrylic insulation sleeve over both ends of each coil. 13 coils, 26 ends. Then they group these insulated wires into large power cables. The number of wires per cable varies according to the speed and voltage of the motor. The grouped wires are soldered together and the cables insulated. Workers tuck some inside the stator and leave others accessible so they can be attached to a power source when the motor is installed. Now, using a cord made of heat and chemical resistant polyester, they bind the coils together tightly to ensure they won't move when the motor spins. This unit of bound coils is known as the stator coil. They now submerge the stator in a polyester-based varnish and vacuum it through. This thorough penetration makes the stator coil moisture resistant. The stator is then put into an oven for 6 hours at 135 degrees Celsius. The varnish hardens, making the stator coil rigid. Now workers have to balance the rotor. If it's off-kilter, the motor will vibrate, hampering performance. They balance it the same way a mechanic balances a car tire, only with 100 times greater precision. Now the rotor is slid into the stator. The rotor will turn on steel bearings. These bearings are heated to expand them, making them easier to install. Then they're blown with cold air to shrink them to a tight fit. It's the same process with the motor's back cover. A fan is then installed over the back cover. The fan's job is to cool the running motor so that it doesn't overheat. The fan is covered with a safety guard. A cover is also installed on the front of the motor. The finished motor is run through various tests to assess, among other things, insulation, power and performance. These industrial motors are designed for use in factories, for running machinery such as conveyor belts, pumps, fans and compressors. We'd be lost without them.